We're going to be learning today. Oh yeah, a couple things going on. So, talk about the binomial theorem today. That sounds like fun. Probably not gonna have time to get to polynomial division that Monday. But specifically, we're going to simplify a polynomial expression with tricks.
How do you do?
And how are we going to do that? We're going to discuss multiple ways of simplifying a polynomial expression. So, let's go ahead. Let's just title these notes. Stay with me. So, let's go ahead and title these notes. Let's just do the binomial theorem. That sounds nasty. Binomial theorem. Now, before we jump into that, let's just play a little game, shall we? I'm going to start a pattern. And your job is to try to figure out what the next number is going to be. Okay? If you think you got it, just smile. Don't say what the number is. Okay? Starts out, goes like this. It goes 1, 1. Yeah, you're going to want to write this down. 1, 2. 1, 3, 3. 1, 4, 6. What did I say? If you think you know the pattern, just smile.
Sorry. Oh, we got it.
Chew on it. Just chew on it. Let it set in. Next row. 1, 5, 10, 10, 5, 1. Chew on it.
I can't rush this.
I got the pattern.
Two more rows.
Oh my gosh.
1, 6, 15, 20, 15, 6. This is 1. Can you see it yet? I see some smiles, but I don't know if they're for the right reason. All right, help me out. Next row. 1, what's next? 7 then. 21 then. 25 then. 35 then. 21. 7. Now, obviously, this pattern can continue forever. What's the pattern? Adding the two numbers above, right? So 4 and 6 together makes 10. 5 and 10 together makes 15. That is right. It's okay. Now, this is what's called Pascal's triangle. It would go on for infinite rows.
It's like
Pascal's triangle. It's just a little pattern. Now the pattern has some mathematical significances. By the way, if you guys in your math classes last year, if you passed the SOL, you got me down to the auditorium.
yeah.
We watched from Osram. You guys know that, you guys remember how one of the guys' names was Pascal?
Yeah.
That's because he's a famous mathematician.
Oh yeah.
Right? So you had Pascal, you had, I think one of the guys' names was Gauss, and I can't remember the other. But anyway, so Pascal is he's a famous mathematician, and he came up with this triangle, which isn't anything too fancy. All of you guys can eventually, even if you didn't see the pattern right away, you can understand how the pattern works, right? Now, I'm just going to ask you to table that. Just keep that in the back of your brains for a second. And let's go on to example 1.
Ready?
Example 1, your job is going to be to simplify the expression. And let's start out with x plus y to the fourth power.
Oh no.
X plus y to the fourth power. You're absolutely right. You should be saying, oh no, right now. Because I know none of you are going to try to tell me that that's x to the fourth plus y to the fourth, right? No one is going to say that mess. Wrong. Angry face. Don't give me that.
Wait.
So, instead, the only thing that you've been taught so far how to do is to write it out 4 times. X plus y times x plus y times x plus y times x plus y. That's kind of gross. X plus y to the fourth power is the same thing, right? Now, you know how to do this piece. That's just spoiling, right? So you can multiply that. And then whatever you get from that, you multiply times another x plus y. And whatever you get out of that, you multiply times another x plus y.
Do you want us to write all that?
It's going to make you appreciate the goodness.
Do you want us to write all that?
So, now I'll give you a little shortcut. What might be a little easier. Let's tell you what. We'll pick it up. Yeah, let's split it up into 2. We know that this is going to be x squared plus 2xy plus blah blah blah. Just go ahead and go to lunch. Bring it back. I'm gonna hush. All over the crowd. So, we know that x plus y to the fourth power, we got to write out 4 times. Now that's going to be a little bit of a pain in the butt, but it's okay. We can manage it. So we go to work. Nope. So, over here, this we can FOIL, like we normally do. If you remember the warm-up, we know it's going to end up being x squared plus 2xy plus y squared. Do the same thing over here for these 2. And you end up with x squared plus 2xy. So you really only have to do one tricky multiplication one, right? Now you can set up your box method. You can set up you can just distribute 3 different times. Either way, I'll meet you at the finish line. Go ahead and multiply those 2 together.
You have to sing.
Finish.
How much you get over
I'll try to.
Yeah, you need to sign that.
This is so Are you related to the sitting over there?
It's just, temporarily sitting here collecting notes. I don't like that part.
What's today's date?
The 20th.
The 20th.
All right. You guys keep working on the catch up.
Yes. Sorry.
Right.
What? X squared plus X yeah. That's not the parallel block.
Almost fell.
Water.
I don't want your phone.
Bam, I got it.
It's you. You get knocked out.
Oh, so the are you going in there? No, I'm going to this room.
You just...
Oh my God, man. 12, 4, 0.
What do you think, Mateo? Uh-oh. Oh my gosh, now I'm confused on this direction.
Alright. You guys get something like that? Alright. It should say, if you did it right, you should end up with x to the fourth plus 4x cubed times y plus 6x squared times y squared plus 4xy cubed.
You're recording this, right?
Plus y. Alright. Now, that was kind of nasty. You could have done it. Hopefully some of you guys did do it. Most of you probably did do it. Here, all I did was I just distributed that x squared into each of these three terms, and I got that first line. Then I distributed the 2xy into each of those three terms, got the second line. Distribute the y squared into each of those three terms, got the third line. Combined like terms. Now, man, wouldn't it be nice if there were an easier way? Wouldn't that be nice?
No, we do it.
You guys remember the objective for today?
What tricks?
With tricks.
What do you want?
So hopefully there's some trick that's going to make our life a little easier. Now, remember I told you guys to log something at the back of your brain. Look at what we have here. X to the fourth, 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. Does any of that look familiar?
No.
X's and Y's. There's no Z.
I'll give you a hint.
The letters and the numbers.
Give me a hint. What happens if I put an invisible 1 here?
It's no.
No.
4, 4, 6.
Oh, 1, 4, 6, 4, 7, 1. Yeah.
Oh.
I seen it.
No.
How does that help us?
Now, there are several different patterns going on here. Number one, if you just look at the coefficients, 1, 4, 6, 4, 1. We've seen that pattern before. 1, 4, 6, 4, 1. That's just the coefficients. Now, there's obviously more than just that in the problem. If you look at the variables for x, it goes from x to the fourth down to x to the third, x squared, x, no x. The y's go from no y's, 1y, 2y, 3y, 4y's. So, without working it out, step by step, if I gave you example 2, let's call it x plus y, to say, let's go to the 7th power. Instead of taking all of this and multiplying by 3 more x plus y's, what do you think? Well, I'll set it up like this. I'm going to give each one of these 3 pieces. 1, 2, plus 1, 2, plus 1, 2, 3.
Oh, I get it.
Mhm.
So
How do you know?
the 1, 7,
What do you know when? If the first variable is going to go all the way down.
Well, let's do this thing first and then see stuff. Alright, so x plus y to the 7th. What I'm doing is I'm setting up blanks. The first one is going to be the coefficient, the second one is going to be x to some power, the second one is going to be, the third one is going to be y to some power. So without multiplying it all out, you should be able to look at your Pascal's triangle and figure out what the heck the coefficients are going to be.
1, 7, 21, 35, 31.
That's the thing.
Well, how did you get that? There's
That's the
numbers
pattern. Right here. Pascal's triangle gives you a pattern like this. So all we have to do is say, oh, we went to the 7th power, look for the 7, and your coefficients are going to be that row. But I think I need one extra.
That's cheating. Stop putting your cheat codes in.
I need one extra.
Are you sure you're
This is
recording?
GTA. I don't use cheat codes.
Wait, why'd you do one
So there's the 1, 7, 21, was it 35? 235? 35, 21, 7, 1. So I already know what the coefficients are going to be. Bang, that was easy.
Well, wouldn't the last one just be x?
We're going to talk about that. Now, let's go and do the x's. Notice here, when I did the 4th power, it went down from 4 to 3 to 2 to 1 to none. So I'm going to take x and start at 7 and go down to 6. Go. 1. And I don't really need this last blank because there are no more x's.
Why?
And after 1 comes none. If you want, you can put x to the 0 power. Makes you feel better.
Can you like make Pascal triangles like up to 10 and just like print them out here?
No. It's easy enough to make in your. Alright, now. So now we gotta do the y's. Be careful because y's don't start. Guys, I love the jokes, but we're not gonna be able to get through this all in the next 15 minutes. Y's, we need to go up, but we don't start at 1. You have to start at 0. So you can, if it helps you, put it at 0 there. And then you got y to the 1st power, y to the 2nd power, y to the 3rd, y to the 4th, y to the 5th, y to the 6th, and y to the 7th. Now that looks a little gross. We have a little extra information there that we don't need, so we can kind of simplify a few things. You don't really need the coefficient of 1, right? So this first one is really just going to be x to the 7th. You don't really need the y to the 0. Anything to the 0 power is no. 1. Anything to the 0 power is 1. So when you see y to the 0 power, it actually equals 1. But I don't need to write the 1, because 1 times anything will just leave the anything. So x to the 7th times 1 is just x to the 7th. Then I don't really need that 1 as the exponent over here, so I can leave him out. If I rewrite the rest to make it nice and neat, then you end up with something that looks
That looks great.
Thomas.
That looks like a lot of rain. Wait, so every time we do this, we have to draw the triangle?
I mean, once you draw the triangle once, then you shouldn't really have to draw it again.
No, like this question comes on the test, like, will they give us a triangle? No.
That pattern's easy enough to make. You just add this stuff to it. Now, this, you know, it's still not necessarily patty cake, but it was a way easier than actually multiplying it out sometimes, right?
Oh, yeah.
That's the binomial theorem, right? So the idea is the coefficients. Here's the bottom line. You get your coefficients from Pascal's triangle. You can all create that yourselves. You don't need me to give that to you. The exponents for the first term in the binomial drop down, the exponents from the second term of the binomial go up. That's simple. What's up?
What if they give you something like 2x plus 2y?
Aha, that's going to be example 3. Alright.
Yay!
Trinomial, notice it's called the binomial theorem. There probably is a trinomial theorem. I do not know what it is. But I assume there's some pattern that could be created. I'm probably not going to give you two. That's just cautious. Alright, what's going on, Mr. Mayor?
So Pascal starts what are force for
Binomials. Binomial theorem. Yes. Notice, guys, this is called the binomial theorem. So what you're taking to a power has to be a binomial. Otherwise, this whole Pascal thing don't work. Now, technically, you don't need to write this down, but technically, let me tell you what the binomial theorem says. So don't write this down because it's just more confusing. You already know what it means. Technically, you would say a plus b to the nth power can be written as p n times a to the n.
It's a number.
Just roll with it right now and I'll explain it in a second. N minus 1 times b. Just chill, guys. Chill out. I know you're excited. You gotta do better than this.
Oh, okay, I see it.
Alright, so this pattern.
Infinity. Actually,
So Mr. Treasure, you learned all this stuff and mastered it?
not master, but
Technically, this is the binomial theorem. If you want to expand it, it's always going to expand like that. P sub n are the coefficients from Pascal's triangle for the nth row. So, like, if you wanted P sub 7, then you need to go to the row that has 7 in it, and those are your coefficients. Then this is just saying your exponents start at whatever the exponent was, and then they go down until they get to nothing. And then the second term starts at nothing and goes up until you get to what the exponent was. It's not the last one. That's the last one. I ran out of space. B to the
they
n.
put it on the dot. It still ran out of space.
What about the one before the last one?
That's the second to last term. So, like, if that were a 7, if you're going to 7th power, then this would be a 6, right? 7 minus 6. And you still have the a. But when you get to the last term, there's no more a. Okay. Like I said, you don't need this part. This is like if you look at a textbook, if you Google search binomial theorem, that's what would come out. But all you need to know is that if you want the coefficients, you get them from the triangle, and then the variables, your first term, your exponents go up, your second term, that's all you need to know. All right, now let's make it a little more complicated.
That's not really possible. Actually.
I'm going to let me insert a page. Alright, example 3.
It's like your UI.
Let's do,
Are you afraid?
I don't want to make it too crazy. Let's do 2p plus 1 to the 5th power.
Can I make 8x?
Sure. If you want to, I'm going to share notes. I'm not going to ask for them. Alright, notice something's a little different about this one, right?
You already had the
Oh,
colors.
yeah.
Yeah, now we got a,
So did you
we got a
multiply?
coefficient there. So, here's what I would do. And I didn't explain this as well as I'd have liked to last period, so you guys are getting the better version of this, right? So, first off, you guys know you're going to probably want to go to the Pascal's triangle, get your coefficients, all that good stuff. Before you do that, I would probably just set up the blanks. Set up the blanks, then you just fill in the blanks. It makes it so much more organized. So I'm looking for, I know I'm going to have a coefficient, whatever the first term is, then whatever the third term is, plus another coefficient, tell you what, I'm going to make this more interesting because this one's too easy and I'm not going to have another chance to give you a third example. I'm going to make it some lights. It makes it a little more complicated.
yay.
Okay? So then I got bang, 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 3 blanks, bang, 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 3 blanks, bang, 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 1, 2, 3, 4. And by the way, you realize that you always end up with one more term than the exponent says. So if you go to the 5th power, you should really have 6 terms. Okay? So I'm setting up the blanks. We're going to talk about that in a second. Right now, just set up the shell. Just set up the shell. All right, now, here's where you got to be careful. We can go ahead and fill in the first blank from all these from Pascal's triangle. If you look at the row that has a 5 in it, I'm going 1, 5, 10, 10, 5, 1. So I know that my polynomial, once I expand it, should be 1, 5, 10, 10, 5, 1. Now, the exponents normally, they take the first term and the exponents go down from 5. Here's what you have to be careful about. It's not just p anymore. It's 2p. So, what I need to do
I got it.
is make sure I use parentheses. 2p to the 5th. 2p to the 4th.
Wait. That's the second line?
Oh, yeah, I'm going to put this on the second blank.
Okay.
If you want, go ahead and put 2p to the 0 power. So all I did was I just marched down my exponents from 5 down to nothing. Now you have to put parentheses there, though. We're going to come back to why you need the parentheses here in just a second, but let's go ahead and fill in the rest. So then I got a negative 1. And if it helps you, you might want to change this to be plus the negative so that you remember that you need to take the negative with that 1, right? So when I go here, I'm going to put negative 1 to the 0 power, negative 1 to the first power, negative 1 squared,
Wait, but doesn't it always
negative 1 to the third.
It's to the power of a negative times a negative 1 and positive.
We're going to get to that in a second. Right now, I'm giving... Some of you guys may not need these baby steps. Maybe you can skip right to it. But this is going to be much more organized for most of you. If I were doing this problem, I would do it like this because there's way too much room for mistakes, especially if you're here writing mistakes. I'm just saying. Now, so you guys all buy the setup, right? This is the same thing that we just did. There's nothing different about this. The setup is the same. All I had to do was throw in some parentheses. But other than that, it's the exact same thing as the last example. If you can understand that, the next part is just arithmetic. It's just simplifying. This is where people got caught up yesterday, but I'm hoping you guys can do a better job at it. If I have 2p to the 5th, I need to make sure, go back to your exponent rules, little flashback. 2p to the 5th, I can think about it as 2 to the 5th times p to the 5th. Oh. I have to make sure I apply that exponent to both of those bases separately. If you don't, then you end up with an answer that's not equivalent. So what's 2 to the 5th power? Don't tell me 10. 32. Alright. 2 times 2 is 4, times another 2 is 8. 16, 32. Alright? So over here, I'm going to have, if I simplify this, actually I probably should have left it.
Wait, where was the note?
It's my little thought bubble. So then I'm going to have 32 e to the 5th. Now, we said anything to the 0 power is 1. I don't really need to write the 1, so I'm just going to leave it as 32p to the 5th. Now we go to the next group. Let's do the exponent first. 2 to the 4th power is 16. So this piece is going to be p to the 4th. Negative 1 to the first power is...
1.
No. Negative 1. Negative 1 to the first power. We're good. Negative 1, I'm just doing this piece. Negative 1 to the first power is just negative 1. Now I got a 5 over there too, right? So when I multiply it all together, I got to do 5 times 16, which is
Oh my goodness.
80.
Stop.
80. By the way, guys, didn't I showed you the trick to do like multiplication? That's a little hard. If you want to do 5 times 16, do 10 times 5, which is
And then 5 times
50, and then do 5 times 6, which is 30.
Who knows the 9?
Because there's a 5 here, the coefficient. Remember, these are from Pascal's triangle. 1, 5, 10, 10, 5, 1. So this 5 is from Pascal's triangle. This 2 got to the 4th, that gave me 16. And then there's a negative 1. So then altogether, that's going to end up being negative 80. This is just arithmetic, people. 5 times 16 times negative 1 is negative 8.
Wait, what? Why did you multiply
Times p to the
Oh.
4th. That's just arithmetic.
Yeah.
We don't like arithmetic.
Now we got less than 20 seconds, so you gotta hustle. 10.
Hurry the night, go.
Nothing there. Okay, 2 to the 3rd, that's gonna give me 8. Negative 1 squared is actually gonna end up being positive 1. So this turns into a positive 1 times 10. Tell me you can do 10 times 8 times 1. That's 80. 80 cubed.
So now
I'm good. If you gotta go, you gotta go. Make sure you check out the video on YouTube so that you can finish it up. The homework, however.
No, everybody leave. Run out!
But it's also online then.
The homework will be online, but you're gonna want your own copy now. Hold on.
will you be able to print it offline?
Alright, let's just finish up the notes here. So we had, where's my cursor? We ended up with 8 times, positive 1 times 10 was 80. Over here, 2 squared is 4. So the p squared is p squared. Negative 1 cubed is going to actually be negative 1. Remember, negative 1 cubed is really negative 1 times negative 1 times negative 1. Negative times negative makes it positive. Times another negative gets you back to the negative. So that's why we have negative 1 here. But don't forget the 10. So 10 times 4 times negative 1 is negative 40 squared. And then I have,
Are you talking to yourself?
I'm recording a video. Good to see you, Prashanta. So then over here I got 5, 2 to the first power is still 2. Negative 1 to the 4th power is going to end up being a positive 1. So I got 5 times 2 times positive 1 is a positive 10. P to the first power, don't write that. And then here, 1 times anything to the 0 power is 1. Negative 1 to the 5th is going to end up being negative 1. So I know it's a little messy. Let me scoot this down. So your final answer ends up being 32p to the 5th, negative 80p to the 4th. 80p to the 3rd minus 40p squared. Hey, what's going on? Minus 40p squared plus 10p minus 1. So once you get this set up, the rest is just arithmetic, and I know the numbers get kind of nasty. You're all big boys and girls. You can handle it. Good luck on your homework.